All right, for this first problem here, we have the circuit shown below. We want to know which light bulbs will turn on, and the key really is, in order for a light bulb to turn on, we need to have a complete path through the light bulb from one side of the battery to the other. So let's start with A. We can start on the one side of the battery here. We can go around through bulb A and back. So A will turn on. That's good. If we think about B, we start from the battery, go around, and we're not going to be able to make it back around because that circuit stops. For C and D, you might think that there is a complete path there, and we certainly can go from the one side of the battery back around, but we end up just looping around. We don't actually continue that loop back to the positive side of the battery. So C and D, in addition to B, are all going to be out. So it's only A because that's the only one with the complete loop. Moving on to this next problem, we want to find the voltage. It says voltage drop, but that's just typically how we talk about voltage here. Across an 18 ohm resistor, if there's 0.75 amps of current flowing through it. So we're going to use Ohm's law here, V equals IR. So our voltage is just going to be our current, which is 0.75 times 18, and we get a voltage drop here of 13.5 volts. All right, for this next problem, we first are trying to find the current through a space heater, knowing that the resistance is 45 ohms and it's connected to a 120 volt outlet. So I'm going to start with Ohm's law for this one again. So we have 120 volts here. It's going to be equal to my current times 45 ohms. I divide both sides by 45, and I get that the current through the space heater is going to be 2.67 amps. Moving on to part B, we want to know the power used by the space heater. So in order to get power, we're going to do P equals VI. So our power here is going to be the voltage, which is 120, times that current we just found, which was 2.67 or 2.6 repeating amps. And if you didn't round it all, you should get a power of 320 watts. If you did, you might get something close, but just a little bit off. So 320 watts is the answer there for our power. For the final question here, we're asked to find the energy used by the space heater over a period of time of 15 minutes. Two important things about this. First, we want to convert that 15 minutes into seconds. So I'm going to say 1 minute is, of course, 60 seconds. And so 15 minutes is really the equivalent of 900 seconds. The other thing I'm going to think about is how we link energy to power, and that is with the equation power is work over time, but work is really just the change in energy, so we can say power is the change in energy over time. So I'll say the power is delta E over T, so 320 watts is going to be equal to the amount of energy we use over a time of 900 seconds. I would cross multiply from here, and what we end up getting is the amount of energy used by this space heater is going to be 288,000, and it's going to be joules because that is the energy used by it. We have another problem here next. I'm looking at a 2500 watt washing machine. That is the power of the washing machine connected to a 120 volt outlet. And so first we want to find the current. So we're going to start with our power equation. Power is just voltage times current. So 2500 is our power. It's going to be equal to 120 times I, which is our current. Dividing both sides by 120 here, we find that our current is going to be equal to 20.8 amps. The second question, we want to find the resistance of the machine. So we're going to switch over to Ohm's law here. V equals IR. So we know our current is, or our voltage is 120. Our current is the 20.8 that we just solved for, times our resistance. So we divide both sides by 20.8. And we're going to find that the resistance of the washing machine here is going to be equal to 5.76 ohms. For the last part, we want to know how much charge flows through the circuit over a period of time of 1 minute. And so for that, we're really thinking about what our definition of current is, which is that current is the amount of charge in a given time. And so we know that our current here is this 20.8. we're looking for the amount of charge, and the time is going to be 1 minute, but we want to have it in seconds, so 60 seconds. From here, I would put it over 1 and cross multiply, and so we end up getting that the amount of charge that flows through the circuit is going to be 1,250, and the units for charge are coulombs. Alright, for our last problem here, we have a light bulb with the power of 100 watts connected to a 220 volt outlet. We want to know the resistance. So you might be thinking, well, we should use Ohm's law to get that. That's absolutely correct. We will need to use Ohm's law. We know our voltage is 220. But in order to get the resistance, we're first going to have to find our current. And so what I'm going to do is I'm going to use this power of the light bulb and the known voltage here to first solve for the current going through this light bulb. And so when I do that, I have 100 watts is going to be equal to the voltage, which is 220 here, times the current. I divide by 220 on both sides, and I end up getting that the current going through this is going to be 0.45 amps. I can then take that and sub it into Ohm's law that I have set up over here, and I end up finding, when I divide both sides by 0.45, that the resistance of this light bulb is going to be 484 ohms. Again, that's not rounding at all. The 0.45 is rounded some, so you may get something slightly off, but it should be pretty close to 484 ohms.